Welcome to your Algebra 2 Lesson 1.5 video number 1. Today we're going to talk about using problem-solving strategies and models. So our objective will be to solve problems using verbal models and some other methods too. It is helpful when solving real-life problems to write an equation in words before you write it in mathematical symbols. This word equation is called a verbal model. To write your verbal or algebraic model, you must use problem-solving strategies such as use a formula. We all know rate times time equals distance, that sort of thing. So consider formulas that you know and see if that is applicable in this situation. The second thing that you want to do is look for a pattern, especially if you've got tables. If you're given tables of information, look and see if you notice that for one of the variables you've got the same amount being added or the same amount being subtracted. Number 3 is draw a diagram. Okay, if it's about placing items or if it's something geometric in nature, see if you can draw a diagram if that helps you work with the information that you're given. Okay, for our first example, this is going to be one where we want to use a formula, and it is a train problem. So, the Acela train travels between Boston and Washington, a distance of 457 miles. The trip takes 6.5 hours. What's the average speed? Well, speed is another way of saying rate. So anytime you have a problem like this and it says speed, think, oh, that's the rate. That's how fast we're driving. It said miles per hour. So we are going to use the good old distance formula for our solution. So you can use the formula for distance traveled as a verbal model. So distance in miles equals rate, which is miles per hour, times time, which is going to be in hours. And so we get 457, because that's the total distance. If you look in the problem, it says a distance of 457 miles equals the rate. That's what we're looking for. We're looking for speed, which means we're looking for the rate. So that's R times 6.5. That's the total time it took. It says the trip takes 6.5 hours. Okay, so an equation for this situation is 457 equals 6.5 times R. We want to solve for R. So we write down the equation. 457 equals 6.5 times R. So we want to solve for R, and the way that we do that is we undo the multiplying by 6.5, and that means we're going to divide both sides by 6.5. So we divide each side by 6.5. You can go ahead and grab a calculator for this. 457 divided by 6.5 gives us approximately 70.3 as our rate, as our speed. So the average speed of the train is about 70.3 miles per hour. Okay, let me switch to the other PowerPoint, and we'll do one more example on this video, and then we will stop this video and move on to video 2 for our last 2 examples. Okay, for example 2, you're going to notice that you're given information in a table, so this is going to be one where you want to look for a pattern. A paramotor is a parachute propelled by a fan-like motor. The table shows the height h of a paramotorist t minutes after beginning a descent. Find the height of the paramotorist after 7 minutes. So looking at this, we can tell that at 0 minutes, that means initially the paramotorist is at 2,000 feet. After 1 minute, the paramotorist is at 1,750 feet. After 2 minutes, 1,500 feet. 3 minutes, 1,250 feet. 4 minutes, 1,000 feet. And our goal is to find the height after 7 minutes. So one thing that would be helpful is to see how the paramotorist, how much of the height is being lost, because the values go down from minute to minute. And if you look, the height decreases by 250 feet per minute. When we go from 2,000 to 1,750, that's minus 250. From 1,750 to 1,500, that's minus 250, and so on. It's always minus 250. Okay, anytime you want to model the height of somebody or something that is making a descent, you can use this particular type of pattern. So we're going to use this pattern to write a verbal model for the height. You always start with the initial, you're going to do current height equals, So we've got height and feet. The initial height, you're always going to start at the initial height, which is the height that the person or object is at time 0. So if you look back at your table at time 0, the paramotorist is at 2,000 feet. Okay, since this is a descending object, the person is starting off high and getting lower and lower, we have minus 250 because that's the rate of descent. That's how much change occurs every minute times the time in minutes. So we end up with h equals 2,000 minus 250 times t. Now, once we have our equation, okay, our equation for the height at any time t is h equals 2,000 minus 250t. We can plug in 7 because we want to know the height after 7 minutes. And so we would plug in 7 for t. T stands for time. And so we get h equals 2,000 minus 250 times 7. 250 times 7 is 1,750. So 2,000 minus 1,750 is 250 feet. If we had wanted to know the height after 6 minutes, we would have plugged in 6 for t. Okay, however many minutes after the initial time, okay, you just plug in that value into your equation. Okay, I'm going to stop this video here, and then we will pick up with a new video and do examples 3 and 4.